Hello students, are you ready to learn electronic configuration today? Yes, this is part 3 of the topic structure of atom on the channel Pen and Paper Chemistry. Here I would request you to take out the charts that I had mentioned in the last video. And we are talking about electronic configuration. What do you mean by electronic configuration? As you can very clearly see, I have written the definition over here. When you arrange the electrons in an atom in the various orbits. Now, if you again recall, we had mentioned according to the Bohr's concept, there's a nucleus and we have these circular orbits around the nucleus. Just like you have different classes in a school. You have class 1, class 2, class 3 and so on. Now, each class has its limitation. Each school has its limitations. It says, okay, we will take 20 students only maximum in a class. Another school says, okay, we will take maximum 40 students in a class. Now, how many electrons, how many maximum electrons can be accommodated in a particular orbit in an atom is what we are going to discuss over here. And how are these electrons distributed, on what rule? We call it as the 2n square rule, where n means the number of orbit. By the way, if you do not have your pen and paper handy in order to take down the notes, please pause the video, get a set immediately now. It will be very, very helpful for you because you will be able to revise it when you do not have access to YouTube. Let's get going. 2n square rule. What does this say? That the maximum number of electrons in any orbit is given by 2n square, where n is the number of orbit. So, what we've got over here? So, if I'm talking about the first orbit means n is equals to 1. 2 into n, right? Here n is 1, so we'll have 2 into 1 into 1. What does this give me? 2 electrons. Now, please understand, it is the maximum number of electrons which are present or possible in the first orbit. It can be less than 2, it cannot be more than 2. It is just like that the maximum capacity of a class, let's say, is 20. The school says that the maximum number of children we will take in a class is 20. So there can be 1 student, there can be 2 students in the class, there can be 5, 6. There can be any number of students in the class up till 20. You cannot exceed the number 20. So same way here, the maximum number of electrons in the first orbit is 2. Would you like to give it a try? Okay, when we are talking about the second orbit, that is the L orbit. If you are unfamiliar about K, L, M and so on, please watch the previous video where we have completely discussed the Bohr's model of the atom. By the way, this video is aimed for students of class 9 and 10th, or what you would call as the secondary curriculum, right? For 11th and 12th, there's a separate set of videos which goes into the details of all this. L shell, that means we are talking about the second orbit of the atom. So, what will be n equals over here? Correct. So, it will be 2. Very good to those who've solved for all the 4. You've given it a try. Those who've not been able to do, don't worry. We are going step by step. If you are stuck somewhere, just scroll the video back and you will be able to do it. But I can guarantee that if you are writing alongside watching this video, I am very confident that you will have understood this topic. 3. The third orbit, that means we are talking about the M shell. So what will be the value of n over here? And what will be the maximum number of electrons present in the third orbit? Calculate. Go on to n orbit. N is equals to 4. That means n is equals to, correct, 4. So what is the maximum number of electrons present in the fourth orbit? Please calculate. So what do we get over here? Yes, very good. It's 18 electrons over here, and 4 times 4 is 16. 16 times 2 is 32. So 32 electrons. So the maximum number of electrons possible in the third orbit is 18. Maximum number of electrons present in the fourth orbit is 32. So you can very easily remember the numbers 2, 8, 18, 32, right? Would you like to calculate for the fifth orbit as well? Come on, give it a try. N is equals to 5. You can post your answers in the comment box if you are unsure about your calculation. Now, let us go on to the next thing that we have to remember. Here, next, when we fill the electrons, when a child enters the school, how does he enter? Yes, we start with nursery, then we start with the kindergarten, then we go to class 1, class 2 and so on, right? Same way, when an electron has to enter an atom, an empty atom, an atom which does not have anything, we say that the electrons will always enter in the order of increasing energy levels. So, an electron will go into the first energy level, then the second energy level, then the third orbit and so on. Yes, energy levels is the same thing as orbits. If the first one is filled up, then it goes to the second one. If the second one is filled up, it will go to the third one. So these electrons enter into the orbits in the order of increasing energy. Let me take an example over here. I am taking a little different example. So let me say I'm talking about 11Na23. Now based on video number 2, can you tell me what this number is? Very good. It's the atomic number. What is this number? Very correct. This is the mass number. What is the number of neutrons in this particular atom? Very good. It is 23 minus 11. Those who are fumbling for answers or trying to find out the answer but are unable to connect, all of this is covered in the video structure of atom part. Right? Okay. Let's get going now. Now, once we've got structure of atom, we've got all these things in place. Now, what do we have to arrange when we talk about electronic configuration? Yes, we have to arrange the electrons. Now, which number gives me the electrons? 11 or 23? Very good. It's 11. So, the number of electrons in this atom is 11. And when I say electronic configuration means I have to arrange these electrons. So let's start with our 2, 8, 18, 32 rule. First orbit, you put 2 electrons. You cannot put more than 2. You can put less than 2, but only when the first orbit is full will the electrons start going into the second orbit. Okay, the second one can accommodate a maximum of 8. So 8 plus 2 gives me 10. We are left with how many electrons? 1 electron. So the electronic configuration of sodium becomes 2, 8 and 1. In other words, if I have to draw the Bohr model of sodium atom. There we go. We have 11Na23. So we have 11 protons, 12 neutrons, and the electrons are occupying the orbits outside. So we have 1 electron, 2 electron. Yes, you can draw the second electron very close to it also. It doesn't make a difference. It's just that it looks a little nice when we spread it out, right? Now, 1, 2, 3, 4, 5, 6, 7 and 8. And finally the 1. Where did I get this from? From the number of electrons, I wrote the electronic configuration. I hope this makes things a little more clearer, because now what we are going to do is write the electronic configuration of the first 20 elements. Let's get going in this. So you remember this chart that we had drawn in structure of atom video number 2, part number 2, and we had made a row over here for electronic configuration. So when I've got hydrogen, number of electrons is 1. So how do I write the electronic configuration? Very correct, it will just be 1. Go on to helium. How many electrons are there in helium? Now here my chart is blank. I am sure that you would have completed this chart yesterday itself. Yes, when we talked about structure of atom according to the Bohr's concept. Now electronic configuration. There are 2 electrons. You arrange them? Very good. 2. We will not write it as 1, 1 because 1 means the first orbit is still incomplete. It has not yet cleared the syllabus of nursery exam. So how can we put it in the next class? Right? Okay. Next go on to the third element, 3Li6. Atomic number, mass number, number of protons, number of neutrons, number of electrons. What's the electronic configuration? Super, it's 2 and 1. Why? Why is it not 3? Because the maximum capacity, maximum that it can hold, the first orbit can hold a maximum of 2. Not more than 2. Yes, it can have less than 2. Like here in the case of hydrogen, it had only 1 electron. But it cannot be more than 2. Good? Go ahead. Beryllium configuration 2 and 2. Now like this in your chart, please draw and write the electronic configuration of the first 20 elements. I have listed their atomic number over here. Okay. So we have 9 for fluorine, 10 for neon, 11 for sodium, 12 for magnesium. Okay, you can start like this. Hydrogen, helium, lithium, beryllium. Go on, write their electronic configuration in the chart. If you have already drawn this chart on an old calendar which had been lying around at home, then nothing better than that because it saves you a lot of time. Go ahead. Very good to those who've already completed. So boron, carbon, nitrogen, oxygen, go ahead, fluorine, neon, sodium. Yes, in the case of sodium, please be careful not to write 2 and 9 because the maximum capacity of the second orbit is 8. So it's 2, 8 and 1. Very good. Magnesium is 2, 8 and 2. Great going. Yes. So this is how this chart comes in handy for you. Go ahead. Aluminium 13, 14 silicon, 15 phosphorus, 16 sulfur, chlorine 17, argon 18, potassium and calcium. Okay. This is what I need to discuss with you. Now potassium 2, 8 and 9. Is that so? Is that what you've written? 2, 8, 8 and 1 is what we teach to the children. Now teacher, the maximum capacity of the third orbit is 18 and you said unless the previous orbit is completely filled up, it will not go to the next orbit. Then how are we putting 1 over here? Now for that, you will have to study chemistry in class 11 also. I will give you a hint over here. What happens here is, here comes a bright student who is actually eligible for class 3, but looking at his intelligence, the school administration says, okay, I think we can give him a chance and put him in grade 4 instead of 3 and let us see how he does. So what happens over here is the configuration for potassium becomes 2, 8, 8 and 1. Same way for calcium, it becomes 2, 8, 8 and 2. Explaining it from chemistry point of view. What happens over here is once the third orbit acquires 8 electrons, it becomes a little heavy. And it feels that if fourth orbit is available, I should let the fourth orbit have this electron next rather than loading myself. And that is where the concept of sublevels and orbitals is introduced in class 11. Doing class 9th and 10th, you don't need to bother. I know there is no option but to remember these exclusive cases, right? So the configuration for potassium is 2, 8, 8 and 1 and calcium is 2, 8, 8 and 2. Now once you have filled up this chart, should I teach you one more concept? It will be easy. You'll like it. Valence shell and valence electrons. Okay. What is valence shell? It is the outermost shell, outermost filled shell, I should say. Outermost shell which has the electrons in it. Valence electrons is the number of electrons in the valence shell. Let's see an example. We drew the Bohr model of the sodium atom, right? What is its electronic configuration? Very good. It's 2, 8 and 1. It's written on the board. Now, which is the outermost shell which has been filled up? So, this is our first shell. This is our second shell. This is our third shell. Yes, it's the third one which is filled last. So, what we've got is valence shell is our third one. Correct? That means N is equals to 3. What about the valence electrons? Now, in this valence shell, how many electrons do you see? Very correct. It's the 1 at the end. So, valence electrons are 1. Let's give it a try to the other elements. Now, let's see over here. What's the valence shell in the case of hydrogen? Of course, it's 1 only. It's the first shell which is being filled up. What about the valence electrons in the case of hydrogen? Now here its electronic configuration is 1. So valence electrons is also 1. What about helium? Now here in this case valence shell. So it's only the first orbit which is filled up. So anyway 1 again. What about valence electrons? 2. Very good. Come to lithium. Valence shell. See over here the first shell, the second shell. So which is the outermost shell? Which is on the outside? Yes, it's the second shell. So valence shell is the second one. What about the valence electrons? Tell me, how many electrons are there in the valence shell of? Yes, there is just 1 electron in this shell. What about beryllium? 2 and 2. Great going. Let's try for boron. So boron atomic number was 5. So number of electrons is also 5. Electronic configuration is 2 and 3. What's the number of the valence shell over here? Yes, it's 2. How many electrons in the valence shell? 3. What about carbon? Number of electrons in the valence shell? 4. Valence shell 2. Able to understand? If not, pause the video. Pick the pen or pick the pencil or pen in your hand. You've got a paper in front of you. Write it. Do it yourself. watching the video will not help you as much as your own doing it. Please try it. And what's the target for you to do is to attempt writing the electronic configuration and valence shell, valence electrons for all the first 20 elements that we have listed. Where is this chart that I'm talking about again and again? Go back to video number 2 on the topic structure of atom for class 9th and 10th. Go back to that video. There I have explained how you're going to draw this chart. And here I've listed only the first 7 elements, right? If you notice over here. I've given you the atomic number and mass number of the first 20 elements in that. Right. Fill this chart for me and get ready to list down the next set of properties where we will be talking about the characteristics. And if you want to understand, in the next video I shall also explain how to determine the period and the group of an element in the periodic table. So this topic will also include a study about the periodic table. If you've been able to understand this topic, please stay connected, because I will take up more lessons and more topics based on your requests. Happy learning to all of you.